Great, great. So how are you guys doing? How is it going? Okay. So did you finish? Did you attempt the pig quiz? Okay. So only Prasant has attempted so far. Okay. Lavanya has also attempted. Okay. Purushottam, Vishnu. Okay. Good. 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 All right then. So are there any questions regarding pig based on our yesterday's discussion? Is there any temporary loading of data? So actually, there is no special arrangement. Oh, okay. So Pratik, I have uploaded in session number 6. Okay. So yeah. So Pratik's question is, I have not uploaded the video of yesterday. Did I not? So in session number 6, I have uploaded. Okay. No, actually, I need to check. I think I have linked a wrong video over here. Okay, never mind. I'll fix it. Okay, I'll fix it. All right. Yeah, you're right. All right. Now, coming back to Chetra's question, is there any temporary loading of data? The quick answer is there is no special arrangement for temporary data. What you can do is you can load the data temporarily and then drop the data. Okay. So, or do you mean to say the temporal data? These two things, right? One is temporary data, other is temporal. Temporal is generally a time stamped number of records. Okay. No, temporary data is not there. Temporary table is not there. But you wouldn't need a temporary table. Generally, why did we need a temporary table in RDBMS? To keep the intermediate data, right? Here, here, when you are, I mean, by keeping the intermediate data, we were able to form the complex queries. But here, every step is actually sort of creating a virtually volatile data sets. Say, for example, A is completely virtual, B is also quite volatile. So, effectively, you wouldn't require a temporary table here. Also, when you're dealing with database, if you are doing a set based processing, then you don't really require a temporary table. Okay. So answer is no. So generally, in those who are not aware about Oracle, let me answer Tutun's question. That is there a table like Dual? So Dual table is generally a sort of a virtual table in Oracle. We can say select one from Dual, and basically Dual is mostly a placeholder, right? You don't require that kind of thing in case of Pig. All right. So all right. Now, so there is something called union, similar to SQL union. So first form is very straightforward. If you have two data, load user metadata file and input one, input two. If you just say union A comma B, so first all of the lines of A will go into C, and then the lines from B will be appended to C, which means A and B are being concatenated and put into C. Okay. Union is not equal to join. Okay. In join, it's like intersection. We pick up A, find all the records which having relation in B, and then we display. That is a join. Okay. Here, first A records of A are printed out, and then records of B are printed out. All right. So it's pretty straightforward. So let me, before we, all right, so we have, I'm just looking for some data. So let's say we have A and we have B, all right? Now, if we, let me run pig minus x local, or actually we can run pig normally, cd as giri make directory pig exa, no, go to data. So under, all right, so let me put A here, copy from local A, copy from local B. Yes, Sasikant. Hi. So basically what I'm trying to do is I just uploaded two files A and B onto my HDFS, and I wanted to demonstrate to you. All I did was copy from local A, and then the destination is dot. Copy from local B, B. So basically I'm uploading B file into dot. Dot is my current directory in the HDFS. I can change my current directory with CD and see the current directory over there using PWD. Yes. So all of you have to go. I mean, okay, let me know. I'm on hold. Let me know when you need. Yeah, I'm on hold. Hi, can you hear me? All right, so we are starting now. Basically, I was explaining that what does a union means. Union basically puts the output into a single basically concatenates output. Let's take a case of, say we have A and we have B, and we loaded it. We say let's say, so here we have dump A and dump B, right? So what will happen is, if you do, let it finish. All right. So A is this, A contains this, and similarly B contains this. All right. Now what do we want to do is, we want to do a union, which is union A comma B. All right. Now if you see, what does C contains? C basically contains A on top. I mean, there'll be four lines in C, and that's it. All right. Let finish. So you can see there are four lines, so one top of another. All right. A contains this and B contains this. And when we do union of A and B, this is what we get. All right. The only thing is that B has come before in the output and A has come afterwards. All right. That's the only difference. Now, if we do if we do a union on schema, then the output is very different. Basically, it tries to match the schema of A and B, and then if you see describe A, so describe A and describe B, describe A, why can't I type it? So you can see describe B, and if you see describe C, what do you get? Describe A, describe B, and describe C. Now, describe C, when you see, it has got three columns, which means that the values of first column are going to be one top of another, while the second column Y, which is not there in the second one, there are going to be blanks, and in the third one also there will be blanks when it's outputting the data set of A. Now, let's have a look. So basically, what do we get out of this is three columns X, Y, and Z, and four rows. Okay, four rows just like this, just that the columns are aligned properly. Here there are only two columns in the output. All right, sounds good to you? So it's basically, we when we have a data set from different sources which need to be put properly into the various fields. So you define, while loading the data, you load the data in the form of values. And similar is true even if you say z comma x. Okay, z comma x. But still, the the values of column X will be placed just below the values of column X in A. Sounds good to you? So you can see here, look at this data set clearly. Here it says A11 space B12. Okay, and let me, to keep a perspective clear. So A11, I mean this one, A11 and then blank, because Y is not there in B. Okay, describe A and describe B. All right, and describe C. All right. So while fitting the data of B onto the output of three columns X, Y, and Z, it has put X and Z, but Y is blank. That is why you see the blank here. Similarly, blank here, and similarly, in case of while putting the output of A onto the C, okay, so Z goes blank, right? So Z goes blank. So everybody is okay with union on schema, right? Now, all right. So just a quick recap of what we were discussing today. Yeah. Okay. If we say C equals join A comma join B. All right. So what does this statement do? Anyone? What is the result? So what will be the output here? Not really. It'll give an error. Your first answers were right. All right. It'll give an error. Because when you are joining two data sets, in case of pig, it is basically going to use MapReduce, and MapReduce on the column which is the key on which the join is happening, and therefore a column is mandatory. So that is the difference between pig's join and usual relational database. There should be a key. Yes, you are right. All right. So, but the join in SQL provided this great functionality of doing cross product of A and B. For example, if you had a table, okay, I'm talking about relational table over here. So if you had a table which contained, say, which looked like this, okay, and say let me say Pavan. Okay. Now B is Giri and Kumar. If we have to find out all combinations of names from these first name and last name, let's call it first name and let's call it last name. If we have to, so this is a table. This is a standard relational database table. First name is a standard table containing only single column, and last name is another table containing only single column. If we have to find out all, okay, print all names, okay, which print all names, meaning a combination of first name and last name. What will you do in traditional relational database? Anyone? So this is our first name table, and this is our last name table. Both are having one columns, only one column. All we want to generate is we want to generate all combinations. We want to generate Sandeep Kumar, Sandeep Giri, Pawan Kumar, Pawan Giri, and so on, right? So what is the command will you use? Yes. So basically all you need to do is select star from first name, comma, last name, and there you go. You'll get all the combinations of all the names, right? But that is not possible in case of pig. And if we want to do that, what are we going to use? So for that, there's something called cross product. Cross product essentially does the same thing. Cross product essentially does the same thing. Picks up all the values from one side, does a multiplication with all other, and so on. All right. So if you have to, multiply, basically find all the combinations of two data sets here, daily and days, you will basically use cross. Next. So just like any other tool, whether SQL or any command line tool, Pig also provides you the parameter substitution. You can specify a parameter on the command prompt and then use it inside the script. The way you remember we were when we run a script, we can say pig and my script name, and in between we can specify a parameter. So here we are defining a parameter called date, which we can use inside this daily.pig like this. All right. So why do we need this kind of functionality? First, imagine that you are running the daily report and your whole of the script is okay. All you need is every day you edit this file daily.pig and you pass in this, change this file, and then execute this. This is heavily inconvenient. This is heavily inconvenient for a couple of reasons. First, user is modifying the script. The one who is running may not know may not know the pig scripting and might end up making mistakes here and there. Second, we do not want our daily.pig to be edited every day. So that is why, or maybe we are running an automation which runs the daily.pig every day. And in those cases, that automation need to open this file, edit it, replace the date, and then move on, which is very inconvenient. That is the reason why these variables parameters are provided. Now, if your parameters keep on growing bigger and bigger every day, you have got hundreds of parameters. Now you can specify those parameters in a separate file, and every day you can pass the file name as parameter. Okay. Now there is something called pig splits. So you can split your data. You can split your data into multiple data sets. If there is a huge data set and you want to just operate on certain sections of the data in this data set, then you might like to use the split command. All right. Split is not like that we are really splitting the data I mean mutually exclusively, meaning if we are dividing the data into two parts, it's not that the data which has gone into part one will not go into part two. It's not that case. All we do is for record by record we put the data into each legs as in different data sets. So look at this, we are splitting w logs here. W logs is a data set which we have formed after loading this file. Okay, these are web logs we have loaded. Now we want to split it into multiple sections, or we want to form multiple data sets out of these logs on which we want to operate separately. In those cases, what we do is we say split web logs into April 3, April 2, April 1, and all the data with the timestamp less than this goes into that, and all the data in April 02, all the data which is for this condition. So each record of W logs is checked against each condition and put into April 03, April 02, April 01. Okay. It's not that if a record coming from W logs is put into April 03, it will not be put any another data set. Okay. So a record can go into multiple legs, right? Or as well as there will be a case that a record from W logs may not go in any of the legs. These are the legs in which the W logs is being divided. So, so basically we can split the data and then you can operate on each of these data sets, just like you can apply group, you can apply filter, you can apply a lot of things on top of each of these data sets. Okay. This is a fairly useful command. And later on, if you have generated some data from April 01 and April 02, you can combine those together. And when the whole process runs, it will figure out itself what is the proper way of execution. Okay. So this division, the splitting of the data happens on the mapper side, and basically we divide the data over there. So there could be a scenario whether multiple mappers will be dividing the data. There could be a scenario that single mapper would be dividing the data. Okay. So pig, because at the last moment when the pig initializes the process of execution, it figures out what to do, how many maps need to be formed. Okay. And also pig tries to figure out if it can combine multiple groups and filters into one. And so basically it's an optimization step. What does it mean by linear execution? That if there was a linear execution, just like yeah, you can say that a legs like a view, right? So if we are, what does it mean by non-linear? That there are chances that this one gets executed later than this one. Okay, if we are running something which depends on this and then this, so there are chances that this might get executed by something I mean later than the one which is in the parallel. So it's not really top down. Okay, it's not really top down. It all depends on the directed acyclic graph which is formed out of the all the data sets. What is directed acyclic graph? We call it DAG. We will discuss it later also. When you form a dependencies of various things from one to another, and when you try to execute the one which depends on other tasks, the based on DAG, directed acyclic graph, we will figure out what all needs to get done. Okay, so for example, to start this webinar, I need to first of all, starting this webinar needs that I have go to webinar in place. Okay, go to webinar depends on few things such as having an account there, having an internet connection, and everything, every software depends on having a hardware in place. So when I say that I want to give the webinar, I want to connect the headphone, i- intrinsically I'm telling that I need to have all of the things in place which require this. Similarly, when I say my C data set comes from B and A comes from A0. So whenever I say that the execute C, so B, A0 and everything on which C depends on will be figured out based on directed acyclic graph which is drawn inside. Okay, a pig continuously keeps on making a directed acyclic graph when you are defining jobs, defining that data sets. So directed acyclic graph is used at lot of places, including your Ant, Maven, Make, and Git, and almost every software at one point of time would require the formation of directed acyclic graph. All right. So basically, directed, because it's a dependency based execution, it is not like your normal program where you say execute this command, then this command, then this command, and once you have all of these things in place, then do this. It's the other way. You say that this depends on this. When I say C equals to filter A, I am saying the C depends on A. When I say A equals to A naught, order A naught by something, I'm saying that A depends on A naught. So that's dependency. Okay. So effectively, when we are coding in Pig, we are essentially defining the dependency. We are not really executing anything unless at a point of time we execute dump or we execute store. Those are the those are the actions that happen that make Pig run all the queries. All right. So so this was the general overview of Pig, and I'm sure if you try to practice Pig a little bit, you will like SQL. You will like Pig more than the SQL. All right. Frankly, most of the candidates have liked Pig very much, as even though they come from a DBA background. Right. Now, for more documentation, you can use this. Okay, we are using 0.13 version of Pig as of today. We might be upgrading it soon. All right. So so everybody got the hang of running Pig on Hadoop 1 or Hadoop 2? Did you guys got comfortable with running Pig? So the difference, Tuntun's question is, what's the benefit of Pig over Oracle? So in Oracle, you write the whole. So there are multiple differences. First, here we are comparing the the data language to a data platform, right? So a better question would be, what is it that Pig provides over what Oracle cannot be? All right. So again, let me be very brief and little bit more rush. So when you deal with Oracle, you basically deal with hundreds of GB of data. But if your data grows beyond that, and there's a lot of unstructured data, you might want to use any of the big data platform. Okay, so the first difference is the SQL which runs on Oracle may not run so greatly here. Let's say it also runs here. So what is the benefit of pig over SQL, right? What is the benefit of pig over SQL? First, SQL does not provide you the constructs for optimizing steps. It tries to figure out by itself, but it does not give you the knobs to control various things. Second, the syntax of SQL demands that you basically give a single statement and get your query done. Okay. While here you always break down your problem into multiple steps, multiple smaller steps. So that is something which is good in Pig other than the performance. So performance of Pig is of course better than any SQL. Now, so how to run Pig file? Basically you put all the, so say we have all those who are not comfortable with VI can use Pico or Nano. You can use Nano A. Okay, we have, okay, and Nano my Pig script. All right. Now let me just create a simple script. Here I can write, okay, A equals to load A, and then I can say describe, or not describe, let me say dump A. All right. Now that is one thing. So I can say pig my pig script. Okay. Now it has started the script. And also note that in Unix you don't require or you are not forced to put a suffix onto the file. Okay. So there is a mistake in our script. That's what it is saying. So what we need to do, it's not able to find our this. So we can say data slash this, and all right. So this way you can define your script. All right. Now you can also, while you are inside the command prompt, you can do exec that script or load that script. All right. So this way we are able to run. Now next question. What when will we go for pick and map reduce? So answer is very simple. You will first, so the main question will remain that whether will you go for pig and when whether you will go for hive, which has a similar interface like pig but provides you nice SQL, right? So the answer is whenever you require an optimization, then you prefer pig over hive. Okay. Now when do you go for pig over mapreduce, right? That is another question. So answer is simple. When you know that the things can be done in pig, you will prefer pig. If you know that it is not possible using pig, there is no such function in pig's library which solves your problem, then you'll go for Java or MapReduce or streaming Java. What is the scenario that is not suitable for pig? All right. So for pig again, since most of the process is batch wise, any real time processing is not allowed. Is not a great solution. Pig is not suitable for the real time processing. because there is a latency. As you can see, whenever we are running a job, it takes a lot of time to get it executed, even though the data may be small. So those are the reasons when we don't use pig. All right. So moving on. All right. So let's discuss something called Hive. All right. So all right. Now, when do you use similar to pig, what we just used, there is something called Hive, where instead of writing the queries in pig, you write in SQL, and that gets translated into MapReduce and get your work done. All right. And did people need to build such a tool? First, there is already a lot of relational and SQL infrastructure. Okay, okay. All right, yeah, that is something which seems to have missed. All right, so okay, thank you. Thank you, Satyanarayan. Thank you for pointing that out. Let me take a little back step. And so there is something called not Hive, but okay, not this one. UDF is essentially a user-defined function. All right. UDF is essentially a user-defined function. And what does it mean that by user-defined function? Like the way we discussed here, that we have Java built in, and then then there is a we can execute any built-in function. So similarly, let me have a look at what is it. right. So let me make it the example which we currently have of UDF is only Hive. Let me let me make a note of it. So what do we want is pig UDF. All right. So you'll prepare a pig UDF example and then you'll be okay. But in general, it's actually fairly straightforward. You basically register your jar and then you define a function. Okay. It's as simple as that. But we'll do that pig UDF thing later on. Right. Can you please explain real-time example that suits only for MapReduce and only for pig? Okay. So, for example, in case of our, in case of, let's take a, I mean, how should I describe this scenario? So, all right. So we'll have give you an example of pig UDF. I think a simple example should suffice for you. And yes. So Satyanarayan's question is the example of pig and MapReduce, which basically is suitable only for these tools. Okay. So so as a general thumb rule, anything that can be done in pig can be done in MapReduce because anything you do in pig, it is under the hood converting it into MapReduce. So if you are not very good with the basic programming language of MapReduce, such as Java or Python, you can continue to use Pig. Pig is very, very straightforward and simple. It doesn't have loops, it doesn't have iterators, all it has is data sets. Okay. Second is when do you use MapReduce as opposed to Pig? When you are not able to execute things in Pig. Let's take a case of what are the functions does Pig provides us. All right. So based on that, I can take you. All right. Also, UDF custom function can be are very well explained here. Okay. I think I have done it for. All right. Now let me go over this. We were talking about functions of built-in functions. All right. So if you have a built-in function, this is fine. All of this is fine, right? But say for example, let's take a case of our problem where we wanted to reverse the string. Okay. The DNA problem where we wanted to reverse the string. Now, here, let's say that the reverse is not there in pig. Okay. Now, you will have two choices. First, you write the reverse function in in pig, and then you basically you basically import that as UDF and then start working, right? So the so or you could straight away go for MapReduce and then start working on that. So basically, what I'm trying to say is if you are able to break down your problem into pig and or if you are able to break down your problem into hive, it's good. But in case you are not able to break down your problem into pig script, then you generally go for MapReduce. Okay. So as I gave you an example of reverse is not there as a function here. All right. In those cases, you would like to go for MapReduce, or you will like to write a UDF. So most of the 90% of the cases or 99% of the cases, you should be able to handle your problem in Pig efficiently. The difference between your Java code and Pig will not differ too much. All right. So those are the few examples in which you would like to go for uh, Pig or MapReduce specifically. All right. Now, I hope that answers. All right. So moving on. Now, there are many people who are not there are a lot of scripts already written in SQL, so it will not be wise to start converting all of that. There is a lot of SQL infrastructure available, so we do require an engine, an analytics engine, for churning the data which is lying in Hadoop, using our SQL or using our SQL kind of infrastructure. All right. So for those scenarios who are not for those who are not comfortable with Pig or MapReduce, can start using Hive right away. And benefits of Hive over MapReduce is very simple. MapReduce, as you saw that, is generally a little bit difficult even for developers. There is a lot of repetitive logic every time you are forming key value pair, and even though it's a simple join, the value proposition of Hive is very straightforward. It is mostly suitable for analytics on data warehousing. Okay. So we analyze relatively static data using Hive, and for the scenarios where fast response is not required. As you saw that MapReduce has a latency. Whenever you run a job, it gets distributed, it takes time, and it has a resilience in case job fails, it tries to run it elsewhere, and so on. So therefore, when you don't require fast response and you want to analyze relatively static data, and this scenario generally arise in data warehousing. Make sure that it makes it easy to port the existing project. All right, let me turn off the phone. So, all right, so it allows querying on HDFS, which is file system, as well as HBase, which is a database in the Hadoop. Okay. Now there are limitations which we should know. The limitations are it does not allow you updates or inserts into a particular table. But what we can do is record level inserts are not possible. Okay. If you want to just insert one record, that's not possible. But what is possible is you can create a table and then start working on it. Import and export of the data is possible, but record wise editing is not allowed. Okay. And hence, this is not greatly suitable for online transaction processing systems. Reason being, queries have high latency, and because the Hadoop is batch oriented, and there is a overhead of MapReduce. Okay. So this is great when you are maintaining the existing data sets. Yeah, you're right. Right. So I'm answering to Tarun's question, who is saying that this is mainly for it is mainly useful in case of static data analysis. Yes. Now here is the diagram which shows you quickly the architecture of Hive. You have something called metastore. Okay. So till here we have discussed earlier there is Hadoop and and something called resource manager and node manager instead of job tracker and name node and so on. I mean that's usual Hadoop, right? Now there is this driver which basically converts a query into the map reduce. Okay, so you say you are using a command line interface here. CLI is command line interface. Command line interface talks to the driver. Driver queries the meta store, and then it makes a call to the master. It makes a call to Hadoop, not master. It makes a call to Hadoop. Now, here there are other interfaces which are provided on top of the driver, such as the web interface. Okay, HTML web interface, which is Hue, and via Hue you can execute the queries. Then there is something called thrift server. Okay, now so web interface is fine. It directly talks to the driver, gives you a lot of inputs. Similarly, command line interface, but there are a lot of database drivers in lot of programming language. There are thousands of people using hundreds of programming language. Sorry, there are thousands of programming language which connect to the database. Now, if you have to provide the connector for all those thousands of the programming language, it becomes very, very difficult for any project. So so any if you are if you yourself are building a service which might require client in hundreds of programming languages, you would like to write your service in Thrift provides you this great way of just writing it once and then exporting it into multiple languages. Thrift supports hundreds of languages, and users from those hundreds of languages will get a driver in their own language using which they can connect to your application. So, following the same philosophy, most of the tools as of today they are built whenever you are writing a service layer, they all are built using thrift server. Okay, so you program against thrift server, and then thrift server generates the client. The Hive client is generated by thrift in Java as well as C, C++, and all programming language. Okay, so whether there is JDBC client, ODBC clients, and all of them connect to Hive driver via thrift server. Okay, they all connect to Hive via thrift server. Now here is a rough example and quickly showing you here. It shows you that first you copy this file onto somewhere and then use this. Okay, then use this. This basically what is it doing is first copying a file onto HDFS, then load the data, load the data from recently copied file into a table called docs. Okay, a table called docs. After that, you start churning the table called docs, and then you can see clearly that here we are basically splitting each word by space, and after that we are doing grouping of the data by that word which is generated here, and once that is done we basically put all of that into word counts and then we are selecting. Okay, So basically all we did was, first we loaded the data, we loaded the text file line by line into one column in this table. Afterwards we broke down the table into one word per row. After that we did a group by to summarize the statistics. Okay, so this would be far more simpler for you to understand. Okay, so Hive gives you that kind of command interface so that you can interpret your data this way. Now, how to get started? You can simply SSH to the server, okay? Or if you are using virtual machine, then Hive would be by default installed in it. If you are using virtual machine from Hortonworks or anybody, Hive would be by default installed. To use Hive, you could use the straightaway simple Hive command prompt, or you could also execute a single query from the command prompt itself without getting into Hive prompt. Or if you have already an SQL, you can execute it by -f. So as a simple, very simple example, you first create a table like X, all right? And let me first, can you see my screen? So I say I created a table X containing a column A, which is an integer. So X already exists. So let me see, select star from X. What does X has? So X doesn't have anything. So I can say drop table X. Right? Now I've created the table, and then when I say describe X, it shows me that A has it got X has got one column called A. After that, we can say select star from A, and lot of things we can do. All right. Now we have created a table that was pretty straightforward. Now for rest of the things, let's have a look at what else you can do from the command prompt. This is the command prompt. This is the Hive prompt. From here, you can execute things like Hive ls, just like Pig also provided you. Okay, you can say dfs minus ls, dfs minus ls. So you can see that. So we are able to interact with HDFS. We can interact with HDFS, and we can also load the any Hive script like this. If we have some Hive script, we can say source my script .sql. Okay, my script, and then that should be good. Now the next is that comments start with dash dash just like SQL. You can also define these kind of environment variables like year equals to 2012 just like we did in Pig. And in case you want to execute a local command, this is a local ls command. You can say exclamation ls minus la. Okay, you can see that. It's just that you remember to put a semicolon in all commands. Sounds good? Now the data types in Hive has been evolving over a period of time. They started with very small data set types. Now they've started to accommodate all kinds of databases data types. So so earlier they started with string, but afterwards, after 0.12, because of Microsoft SQL Server, they ended up having varchar. Then after some time, because of Postgres, they ended up having char. So there are all kinds of data types available so that you have minimum number of compatibility problems. All right. Now, so though these are very basic data types, and you have also something called complex data types. A complex data type is essentially a composition of the primitive data types. A complex could be an array, a map. Array is a zero indexed hash table, meaning values are put into array, and you can access them. You can access the element by their number. Map is key value pair. Key can be of primitive type, while value can be of any data type. Now, the only thing which is different here is union. Struct is also clear. Struct only has those predefined column names. Struct sounds like map, but in map you can have any primary key, but I mean any key. While in struct you can only have those predefined few keys. That's the only difference. Now there is something called union. Union is little different, and so anybody knows about union kind of a data type? We are not talking about command called union. We are talking about union data type. Those who are from C background, they would know that there was a data type called union. Anybody remembers that? Okay. Okay, yeah. So yeah, something similar to what Prashant is describing. So basically you can have multiple data types into one. So there is a column. There is a column. You know that in this column there could be integer or there could be string. Okay. And you want to deal with both the things. In those circumstances, you generally create a union data type with string as well as integer. And in a union, you can only store one of the two. Either you can store integer or you can store a string. If you have defined a union of type string comma integer. Okay. So it's a single storage for both the data types or multiple data types, but there will be only one value stored at one time. Okay. Now, say for example, we are defining something called a table called employees. We defined a name as a string, salary as float, subordinates as array of strings, deductions as map, as in on what basis the deduction were made, and addresses as in address could be a struct which has street name, city name, state name, and zip code. And there could be a parameter called auth, the kind of authentication we are allowing for the employees, whether it's based on Gmail, whether based on uh, email ID or based on Facebook ID. Okay, but authentication will be only one way. Cannot be that a user can have multiple authentication. It will be only one. So in this example, you can see that the auth variable will only have either of Facebook ID, Google ID, or email ID. Email ID. Okay. So here you can put it like a string, and here it could be an int. All right. So that is the thing. So you can store only one, and the data. I mean the space consumption by union will be equivalent of the biggest of the three data types. Now, so similar to any SQL, you have got databases. Databases basically show database, create database, or so when you are working on Hive, right? Before you start manipulating data, okay? you should create your own database. So create database Asgiri, for example. So Asgiri is existing already. Okay. So I can say show tables, show databases. Okay. So you can see there are many databases. Okay. So you should create your own database parallelly and then start working on that. So all your work will go into that database. So you should go on to, as soon as you log in into Hive, you should always say use database and you use your own database. Okay. That's the purpose of databases, to separate the tables of one user to another or one application to another. Okay. And if you want to go a little fancy, you can also set this. Okay. So now you can see that my current database is Asgiri on the prompt itself. Okay. Now, if you want to delete your database, you can delete your database like this. You can say drop database. Now, the tables are these SQL tables. The command is similar to your standard Oracle. You can say show tables, and then you can say select star from my table. Then you can say describe my table, and so on. Describe extended. So the one which is most useful is this. The one which is most useful is this. It shows you very clearly. Show I say show tables. There is no table right now, and use default and show tables. Okay. Now you can see that here, if we have users underscore data, we can say that describe formatted. Okay, here you can see the full detail of a table. Where is the data lying? Okay, you can see the full detail of the tables. All right, now there are basically two kinds of tables: managed tables and external tables. So we'll discuss these tables in detail after the break. So let's take a break of maybe 5 minutes. Okay. All right, so I'm back. Should we start? Should we start or wait for some time? Looks like there's nobody. All right then. So, so we are talking about. So is everybody in? Should I start? Can you hear me? All right. So basically, there are two kinds of tables in Hive. All right. So the general flow in case of Hive is we create a table, we load the data into it, then we do the analysis. All right. So the first syntax is that we create a table. We can create something called a managed table, or we can create something called external table. The only difference between the two kinds of table is while you are dropping an external table, the table data does not get deleted. But if you are dropping a managed table, the table data gets deleted. So whenever you are creating a table, you define that this is my table and this is the data which I'm going to, this is the location of the table. Okay, so every table has got a location. Now in case it's an internal table, that location will be will be deleted as soon as you delete the table. Internal or managed is the same thing. Oh, is it? Is the voice breaking? All right. Is it better now? Good. Good. So, Hive Meta Store is something which stores the metadata. All right. So, whenever we are creating a table, the we define the columns, we define what are their data types. All of that information is stored in Hive Meta Store. Okay. Even the namespaces, the database, everything is stored locally on a Hive Meta Store. And Hive has its metastore running on one machine where Hive keeps on connecting and storing the data. All right. So the metadata also includes the name of table, columns, partitions, which name of all the tables, list of all tables, list of all databases. Then there is something called the way you define a managed table, which is an internally managed table by Hive, is you simply say create my table, then table name, then columns, and in the end you will see that row format delimited fields by tab. Fields are delimited by tab, and similarly we can say rows comma rows terminated by slash n. Okay, so that way, you basically are saying there is a plain text file containing a new line, and the fields are separated by some separator. You store the data there. So we talked about two things. First, the data of the table and the metadata of the table. Metadata is what are the columns, what is the description and everything, while the actual data is stored in HDFS file. Okay, HDFS, the actual data is stored in HDFS file or file on the HDFS, but the information on of a table like the columns, the name of the database, and etc. is stored in the Hive meta store. So, and the other syntax you'll notice is the location of the table. Location of the table. You need to define that where is the data going to store on HDFS. All right. So when you load the data into NYSE daily, the data at that location will be automatically pushed. All right. So whenever you are loading the data into NYSE daily, the data will be copied onto NYSE daily file slash data slash NYSE daily. So that is important. Now there are few things you should remember. Then when you are loading the data into a table, if you are loading from the local directory, if you're loading from the local directory, the data gets copied onto HDFS. But if you are loading the data from an HDFS file, the data is actually moved to that location. All right. So let's have a look. All right. So the syntax for loading data is this. If you're loading data locally, it is load data local in path this, and then you load the data. Okay. Overwrite into my table. So let me create this table. Most likely this table exists. So I say use as Giri and then, alright. So I have successfully created a table. If I say describe formatted and I say NYSE daily, I should see all the details related to this. Alright. So all the details related to the table you can clearly see here. You can see what are the columns, what are their data types. You can also see the detailed table information. All right. And it also tells you that this is where my data is located. Okay. So since that file already exists, let me open pig on one console. So just to check, so I'm using pig on one side and no, not this. Not this. I need to SSH first. It's actually running pig in local mode because it doesn't know the HDFS. All right. So you can clearly see that what are the things. I want to use pig for browsing my folder structure because that is fairly simple. So here you have NYSE daily already there, and so if I go NYSE underscore daily, so there is no data right now. All right. So if we are importing data to this file, we will be using this syntax if we are loading data from local. And so it says that we need to remove that new line. Okay, so we have actually copied the data into NYSE daily. Select star from NYSE underscore daily. Sorry, select star from NYSE underscore daily. What is the table name? Table name is this. Okay, select star from. So now you can see that the data has been successfully loaded into the table. Okay, it's the same table which we were using for pig also. This one, now you can see few things. We can say select star from this and start grouping and do all sorts of magic. All right, those who are comfortable with SQL, they will be very happy to being able to load their data to SQL from HDFS. Okay, now you can start saying select star from NYSE daily uh, group by some column whichever you want, and so on, right? See, if you want to copy the data from HDFS, you will have to use the same command, except you will just remove this keyword called local from it. All right. And now let's have a look at where did it store the data. So you can see that my present working directory is on HDFS here, data NYSE daily. Okay, I'm using pig to browse HDFS. So it shows that under here there are tables which are created. Okay, so let me have a look. What is it doing? It says that there is a table called NYSE. So NYSE is a table, and R3, when it displays R3, it means the replication factor is 3. Okay, which means it is a file. And how does a file look here? So cat my file. So all right, so this is my actual file. All right, so basically it only copied the data as such, whatever was there locally, onto HDFS, and whenever we are querying the table, it's reading from HDFS and displaying it to you. Okay, so the data is there, lying there. And all right, so remember that whenever you are copying the data like this, whether it is internal managed table or external table, if you're copying from local to a table, then your data is getting copied. But if you try to load the data from HDFS, the data gets moved. Let's take a case of this. So I'm in my home folder, and let's go into this one. Under here there was a okay. Okay, so let's say we have just copied data from somewhere to the current folder. Okay, and now we are trying to load the data from this HDFS file into NYSE daily. Okay, now this file will get deleted after this. So it shows you that moved this file. So whenever you load the data from HDFS to table, the data gets deleted, moved actually. So the data gets moved to into the location of the table. Okay, that's a design decision taken by Hive. All right. If you do not specify a terminated by /t, it expects the data, the fields, the columns. The fields or the columns or the data need to be separated by /a or control A, not /a. Control A is a special character. And whenever you're copying the data, it will create the directory for partition, if any, and then copy the data. Okay. Now, what is the partition? We'll discuss it soon. All right. So now since you have loaded the data into table, you can simply say select star from NYSE daily, where my symbol equals say CVA. Okay, Now you can see that this also launches a map reduce job exactly like pig. All right. So you can see that we are able to launch our Hive queries using just like our SQL. Now, if you don't define the table location, the default data is stored in apps Hive warehouse on HDFS. Okay. But in our case, we mentioned the location, so the data will be located at that place. All right. Now you can see that we have been able to successfully filter the data happily from a big HDFS file. Okay. So basically, Hive makes it possible to run SQL queries on humongous data, on humongous unstructured data. Okay. Also, if you want to take the data out from a table and you want to keep it somewhere, you can say insert into that local directory and select the data from that particular location. Now the data will come to local directory and will get stored here. Okay. So that's to take out the data from a table and keep it on the local file system. Or you can also say insert override directory and then give the directory's name. In this case, because we have not mentioned local directory, the data gets stored in HDFS. Okay, sounds good to you, right? So this there are something called partitions in case of Hive. Okay, partitions are essentially creating different files for different sets of data, right? So as we noticed that in case of a Hive table, we are storing our data into an HDFS file. Hive is essentially providing you a query interface to query the data located somewhere, right? Now, sometimes it is important to keep the data separate for a couple of reasons. First, whenever you are doing a select query, Hive is going to scan the whole data. There is no concept of indexes as such. Okay. The Hive is going to scan the whole data. And to avoid that, you can create partitions. Meaning, for each section of data, we can create a different file. Okay. So based on the where clause, Hive decides where to query the data, which partition need to be queried. Okay. Also, you can define a partition on multiple columns. And in case you are adding a partition later, in those cases, you have to manually move the data. Now, say for example, we have a table called cat, let's say, so we have Asgiri, Hive, and we have a table called the employee. Okay, it has got these two rows. All right, and we have got a okay. So we created a in Hive. We created. Let me launch Hive. In Hive, we created an employees table for this data, and then we loaded that data. Okay, so we can actually load this data multiple times into our table. Okay, use as Giri, and then I created a table. Create table, I specify these three columns, and my data is separated by comma. Now, what am I trying to do is, once this is done, I will basically check what is there in my warehouse employees. There is already some data over there. Okay, there's some already some data over there. Let me first drop that data, delete, drop table employees. Okay, now that data will get deleted. Oh, am I creating an external table? All right. So let me try to understand what's going on. Hadoop fs minus rmr. All right. So we have deleted the data. By default, the data moves to the trash when we are dealing with. So we have deleted the old one. Okay. And what we can do is, so now, all right. So there is no data right now. Now, when we are loading this file into a particular s- field, so here we are defining a virtual column. We define a virtual column called qualifications. And in this, we are trying to load the data. Okay. In this, we are trying to load the data. So if you see, the data has been copied. Okay. And if we say select star from employees, it'll show you these four columns. The fourth one is the partition column. Partition column is essentially another column. It's just when you are defining your table, you don't define the fourth column. Okay, the partition column. Now, if I do select star from this, where qualification equals 1. Okay, so it gives me the result. Now in this case, since I have defined that load my file into table into this particular partition, okay, similarly we can say this. Now we have same copy of the data twice, and let me, all right, now you can see that there is a two sets of data with this partition, and actually the data is located in two separate files. Okay, now since I have created a folder called as Giri here, so sgiri.db will be mine. Now under that it has stored this as two separate files. You can see that. So we created two partitions, and it has internally created two portions in two files. Which means when we query for qualification equals to 1, it doesn't have to open both the files. It will only open that section of data. So this makes our life fairly easier. So when we say where qualification equals to 2, it will basically load only the second part. And that makes it really, really faster. Yes. So if user did not mention any partition, then Hive does not have any partition in the table. So can we do the partition column in the beginning of the table? The answer is no. It has to be the last one. I did not see the syntax yet. Oh, I haven't seen such a syntax yet. So because I also try to do the same thing, but that's not something possible. Okay. Now, so that is the use of having the partition in the HDFS. Okay, that's the use of having partitions in the HDFS. Okay, also to modify a table, what you can do is you can say alter my table and then rename rename a table to something. Can partition data again partition? So basically you will have to remove both the partitions, the partition you want to again partition, and then load the data again into two different partitions. Yeah. Yes. The kind of example we have given is that partition. All right. So if you are defining the partition on current timestamp, then for each timestamp there will be a separate file. Instead of that, that's what you would not like to do. Instead, it should be something like a date. So yeah, partially it is like an index, but indexing is not something is which is there yet in case of Hive. So and most of these big data systems they don't have indexing. All right. Now to change a column from one data type to another, again, all alter table syntax is exactly like Oracle or MS SQL, and you can also add more columns into a table. You can also drop a partition. Okay, so we can say here alter table employees and then say drop if exists partition and we say qualification equals 1. Okay, so a partition has been dropped. Now if you see what is there in employees, only one portion of the data is left. And here also in the file system, the folder containing qualification equals to 1 has been deleted. See? So only one portion of the data left. Okay. If we got the data columns cannot rearrange, but I want to do partition. But the column is in the beginning of the table. So your approach should be that you first load the data into one table and then you do the way we moved the data from one table to another, you can do it that way. Okay, or you can create a view, and then from that view you can put it data into this partition, and once that is done you can drop the old table. All right. If we got the data, the data columns I cannot rearrange, but I want to partition. The column is in the beginning of the table. What would be the, yeah, so the approach will be what I just described, right? So basically you'll create a separate table and then you will move the column, because I was also trying to do the same thing and I could not figure out a syntax where I could define my fourth column in the beginning and a partition column in the beginning. So that is a little bit of a tricky thing. Also, if you notice that we are creating one column, okay, we are creating one column by mentioning that we want to create a partition and the name of the partition is this. Okay, so it will automatically be the fourth column. If in the real life you want this fourth column to be somewhere else, okay, then you can make a selection. And moreover, in the physical data this fourth column does not exist. The fourth column on which you are doing the partition, it doesn't exist. Okay, so when we basically qualification is a virtual kind of a column, it doesn't exist in the data, right? As you can see that qualification, if we have to do this, so in the real data it doesn't exist. Okay, so in real data it doesn't exist, that column. Okay, so it's only in the table as the last column, and whenever you are trying to push it somewhere else which is requires different order of the columns, you can always put that column in the select. How to make partition mandatory while querying? You cannot make a partition mandatory in the querying. Okay, you can only write a wrapper over the existing query and then inform the user. Okay, but I mean that the Hive does not provide such constraints. All right, now moving on. Now for further optimization of the data, further optimization of the data querying, Hive provides something called bucketing. Okay, so bucketing is good when people are querying your data and you want to provide something like an indexing on top of Hive. Okay, this is not really indexing, but this is sort of an indexing, an alternative to it. So what does it do is, when I say cluster by user ID and sort by view time into 32 buckets, so whenever user is querying the data, okay, whenever user is querying the data, the query gets divided onto multiple nodes, and the overall you get the results fairly faster. Okay, so when we say cluster by user ID, which means we want to divide the data by user ID, and on each of the cluster, each of the nodes wherever the query is going to go, the data will be sorted by time and there will be total number of 32 buckets. Okay, In our project, we can't query Hive without partition column condition. I'm wondering how it's done. Okay, let me have a look. Maybe there is a wrapper or something. So, okay, all right. Yes, bucket will always have sorted data if you say sort by. Okay, all right. Here there is some more syntax you can see that I'm saying the field is terminated by this special Unicode character, and my collection items are separated by this. Map keys when we are loading are separated by this. Okay. Collection item as in if you're loading an array, those will be separated by this character while loading the data. And if you're loading the keys into map, so the key and the map will be separated by this character. All right. Similarly, there is something called external table. External table and internal table, there is only very thin line of difference. External table, not really. 32 is not the maximum bucket as per my understanding. Okay. All right. So while reading the data, if your table is external, which means your data is not really lying by default on HDFS, it can also lie somewhere on the internet. Okay. Also, the other benefit of having external table is that when you drop this table, it doesn't touch the data which you are querying. So generally, as a matter of habit, you should be creating external tables, because that performance wise there is no difference. The only difference is when you are deleting a data, you will not be deleting the actual. When you are deleting a table, you will not be deleting the data accidentally. Okay. So, so other than that, the other differences of external table is that you can load your data from existing existing S3 bucket. S3, Amazon S3 provides you buckets and you can load the data from there. As well as you can load the data from other places. There are many kinds of resources allowed on Hive external. Okay, so here we created external table called mini wiki stats, and we provided columns, then partition the data by one particular column, and then we said that load the format. I mean, row format is this, and line is terminated by slash n, and so on. Okay, here it's slash n. So we know that our data which is lying in S3 bucket, okay, is of this format, this format. And so we created this kind of table. So every time we are going to say select star from mini wiki stats, it is going to read the data from S3 location bucket by bucket, and then not partition by partition based on your query. All right. So this makes external table fairly useful, because a lot of time you do not want to download all of the data and then do the filter. Say for example, Amazon provides a public data set in the form of S3 bucket. So you can download the data from there. Now imagine that you are trying to query all the Wikipedia data, right? So, and you don't have, say, 500 GB space. All you want is a portion of the data from S3. So you can directly create an external table pointing to S3 and then you can download portion of the data and push it to your HDFS. So that makes it possible to remotely query things. Okay. So basically, based on your query, it will figure out which partition we are talking about, and then it will try to get only few chunk of partitions. Okay. So that is the benefit of an external table. Okay. Now, external table can also be partitioned the way we had partitions for our internal table. Here, the good point is that you don't need to define the location of the table upfront if it is partitioned. Okay. And each partition when we are adding, is it breaking my very much now? Right? Right? Not clear? Not clear? Is it clear now? Is it better? It's still breaking. Okay, so it is clear now. All right. So you can also create external table without defining a location, and because external table doesn't need a location right away. If it is partitioned one, it doesn't need a location right away. If we get a data from RDBMS, is it need to store in HDFS? Can we process through directly? So, so if you can process through directly, you can anyway process through directly, right? Although it is easily possible to connect to your RDBMS from Pig, from Hive, or from MapReduce. Okay, so you can use a proper catalog to load the data from these places. All right. All right. So here, what I'm trying to demonstrate to you is that we created a table without a location. Now we are adding partitions to it. Okay. So we added first partition of 2012 and 2nd of January. This data is lying in HDFS at this location. Now we added second partition from a different year, month, and day, and that data is lying in S3 bucket. Now, out of all of this data, we are able to form a singular table. The only condition here is that the data format should be similar. Okay, data format should be similar, and hence we can load the data from these locations without worrying too much. All right. So basically, external table makes it possible to load data from multiple different sources from all across, and we can continue to use a table as if it's a single table. But every time you query, it does lot more to optimize your query. Yes, always partition happen on individual column value. You can also combine multiple columns, okay, but it has to be of the value. All right. Now, here are few notes for you. Here are a few notes. First, each table has got a location. By default, that table is each table has got a location, internal or external. Why? Because that's where the data lies. By default, that table is in a directory called app hive warehouse. You can override that location by mentioning location in the create table clause. You must have seen this. So it's a sort of a recap of couple of things. Whenever you load the data from local, it copies. If it is copying from HDFS, it moves the data. And whenever we are loading the data from HDFS into a table, the data is moved. If we are dropping a managed table, it it deletes the data. If we are dropping an external table, it doesn't impact the data. The metadata is stored on a relational database. Okay, so Hive meta store is something which comes embedded. You can configure your Hive to start storing metadata in MySQL or any other database. All right. Now select statement is standard. Select name, comma, uh, select column 1 comma column 2 from employee, and that's all. Similarly, we can do the projections as in computations on the column while doing the select. So here we are saying select to upper and then name and then salary. Upper is a function and deductions is a hash map. Okay, deduction is a map, and then we are doing a full mathematical operation in this. So select statements are standard select statement, meaning you can do computations during selection. Okay, there are some aggregations, the count star, average, all of those things are in place exactly the way it is in Oracle or MS SQL. So select department count star from employees group by a department. Okay. Now sometimes you want to improve, you want to basically optimize few things, such as you want to shift lot of data churning to the map side itself. You can do that by mentioning that do the map aggregation Hive map aggregation equals to true. So lot of data which can be churned on the left hand side itself, as in maps itself, can be done there. Okay. So for example, we are doing count star here or average salary here. Actually, this could be done very easily on the map side itself without getting on the reduce side. Okay. So similar to MS SQL, we have something called views. We can create a view on top of other tables. Okay. So we have said on top of other queries on various tables. That simplifies our life as a query. As you can see in your exercise, in one of the exercises where the project one is there, most of the work is about views. Okay, most of the work is about views. You can see here we are saying at the end that create view L3 as this much, while L2 is also a view. Okay, and L1 is also a view, and so on. Okay, so here the I mean, if you see there's a views on top of views on top of views, and that kind of, I mean, the views gives an enormous amount of capability to separate out the queries from one another. Okay, so views is like pig's data set. Every time when we do query, we say that okay, B equals to filter my A by these columns. So B is basically a view on top of A's data in pig. Similarly, views are also there in SQL in this form. All right. And you can do left outer and all those kind of queries which you have learned You can do all of those queries in views as well. Okay, and then all right. So rest of the SQL is as is. Whatever you define is there as such. Okay. But sometimes when you are dealing with lot of data, your data might be structured, unstructured, and can be, you might require some functions which are not there in the standard library. In those cases, you can create your own user defined function. And this is done using Java. So all you got to do here is create a class called lower, extend UDF, and then write a function called evaluate. You write a function called evaluate. Okay. So for every function, if you have 100 functions, you will have to create 100 classes. And each of those 100 classes, you will have to define a function called evaluate. All right. Good. So here, basically, this is what it returns. Now, so you create a namespace, import a proper, packages. The source code of all of this, along with the libraries, is available in LMS. Now, what you can do is you can export this data, this project, into say Hive UDF. Okay, and we say Hive UDF, and then it is loaded. After you are done with this, you should copy it to your folder. So let me see if I have copied it already. So I've already copied it. You can say under Hive, you can say add jar Hive UDF after transferring it to the machine which contain add jar Hive. You should first transfer it to Hadoop 1, Hadoop 2, or wherever your node cluster is there. Need to transfer it there. Okay. Now I have added it. Now here there is a function called lower. So I can say select star from the tables which I was handling, employees, right? Now I want to do, okay, I want to, there is no example I could show you here. Let's say I want to make it lower in case of, just for the sake of argument, I want to make it upper. Okay. Let it be misnomer for some time. Okay. So this function is essentially doing an upper. So I hope that my function should override it. Let me copy the data from my local machine. Okay. And so copy from my downloads folder. That's where I exported. Hive UDF, and so it's copying the data. This looks pretty big. All right. Now let's see what happens when we say select. Let me see, describe employees. Okay. Now I say select, what was the name? Lower. Select lower, and I say name from employees. Let me see what happens. So here, I hope this is clear to you. So these are the steps. So create jar, add jar to your add jar, your jar after you have transferred it, and then you define a function. You don't have to put your jar onto HDFS. A local file is good enough. And then here you need to define this function first before you do anything. Okay. This did not find our function. So, okay. And here we've defined my lower. And since our function is the other way, it should actually make everything uppercase. Let's see what happens. Right? So our lower function actually converted into uppercase, right? Because that's what we did in our code. All right, that's what we did in our code. So we were successfully able to define our UDF. We can do a lot more. Say, for example, our task is to replace, to convert something into MD5 hash, or our task is to convert some generate some do something which is not there in Hive. In those cases you will write your custom Java function and you can use this. Also also you can actually write your own reader writer. Okay, you you can write your own reader writer in detail. If you want to read, you can see this example. Okay, all right. So there are a lot of things you could do using UDF. Okay, say for example you want a new kind of a factory which reads the data from log file or something. You can write those kind of readers using this. Okay, so those are the custom functions. Now if you want to load, say Java JSON function. What is JSON? Can somebody tell me quickly in single words? What is JSON data? What is the full form of JSON? JavaScript object notation. Okay, so every JavaScript object, when you're defining JavaScript object, you can define it in JSON. Okay, so it's a very neat format and lot of people use it. So so in case your data input is available in JSON, and the data you want to load is in JSON format, in those cases you can use this library which is available and then load that. Okay, now how do you do that? First you download a JSON Serde. Serde means serializer deserializer. Okay, so whenever you are writing a custom way of loading data into Hive, you implement Serde. SERDE. SER means serializer, DE means deserializer. So there is a Serde available for JSON kind of a data available online, and for most of the formats you will find Serde available online. here and there. Okay, so you can just find the survey of the your data which you want to load, and then download the jar and do add jar, and then you put all the put the jar. And once you have done that, you can start using that survey in this way. Okay, here it says this: create my table, my external table, the table name, and all of that, and define the row format as provided by this external class. Okay, now before a data get loaded into the table, it will be given to the survey, and survey will give you the JSON survey will give you the data in the form of rows and columns. Okay, so that is a nice thing about flexibility provided by Hive as well. Okay, so in case you want to implement your own survey, you can implement in the same way the way we had implemented our UDF. Okay, and put it in jar and then load it. All right, so when we are talking about Twitter data, so the data which we have available of Twitter is in the form of JSON, and we will be loading it using this library. All right, now similarly, when we do order by X, it it guarantees the ordering of the data, but this logic is executed only on one reducer. All the data is collected, gathered, and then done on a single reducer, which is kind of weird. Okay, this is kind of weird because it will basically overload one reducer, and then your machine will be overloaded, and you may not be able to solve the problem. Okay, so this is completely unacceptable when you are sorting the large data sets. Therefore, Hive guys came up with a syntax called sort by instead of order by. Order by was the default old one. Now they came up with sort by X. Orders the data at each n reducers. Each reducer, so these sorting is happening on multiple nodes now. Each reducer can receive overlapping ranges of data. You end up with n or more sorted file with overlapping ranges. Okay, so that is the problem with sorting. Sort by X. So what is the solution? For basically you combine sort by and distribute by. So first you distribute to all different nodes different sets of data, and then such that the data is non-overlapping. Okay, so that you don't have to merge it later on. So therefore you first distribute by X and then sort by X. Okay, that will ensure that you have a proper sorting of the data in place. So that so the distribute by and sort by was combined into one, saying cluster by X. Okay, which essentially creates n number of reducers separate, having separate key values, which are each of that data is sorted individually and then combined together easily. All right, so this is basically more scalable version of order by. Okay, now as a quick demo, actually the demo which we have already given is straightforward. You should take it as an exercise. Basically you should download this movie lens data. Movie lens data provides you this movie lens data provides you the data available online of the ratings given by various people. Now you download the data, you can use curl or wget. Both of these are very powerful tools to download data from net. You can download the whole websites with these, and once you download it, unzip it, and then Once you have unzipped it, you load your data into the table which you have created above. After that, you can start playing around with these ratings, and you can, I've already done all of this. Okay, so I think it will be straightforward for you to load this. All right. Now, okay. Now after that, you can start doing a lot of magic on top of this table. So take it as an assignment, load this table into the memory, okay? And I mean, try to do various kinds of computations, such as how for each movies how many users have voted it, for each movies what is the average rating. Okay, try to do these computations on top of this data, and try to do a computation such as, for each movie, compute the average rating for only those movies which have got minimum of 20 ratings. Okay, try to, and rest of the movies you should ignore. Okay, for each movie what is the average rating. Okay, for movies having more than 20 ratings, more than 100 ratings, or maybe I think 20 is better because the data is just 1 million records. No, it's 100,000 record, 1 lakh only. Okay, so try to do this, it'll be a good exercise. Okay, and yeah, I think this will be useful when we, yes, yes, you are very right, Prashant. So you are talking about cluster by, right? So cluster by is the syntax if you want to sort the data. Okay, don't use order by, distribute by, or sort by. Use cluster by. Okay, that will make your life easier. It's as simple as that. Now let me talk. So this is all about Hive. You should start using it and playing around a bit. And if you have any questions direct, you drop us an email, then we'll respond to it. Drop us an email at hadoop at nobigdata.com or sandeep at nobigdata. Either one is fine. Okay? Uh, all right. Now, all right. So tomorrow, as in on Monday, we will discuss something about NoSQL. We can get started now. Okay? We can get started now. And then, oh, right. Monday is a holiday. Then you'll have to do it on Tuesday and Friday. Yeah. Monday is a holiday for all of us. All right. So we'll continue on Tuesday. We'll just say hello to our NoSQL and HBase course. All right. So here is our, basically we are going to discuss something called NoSQL and HBase. And yeah. So that's pretty much from my side. And let's actually continue it because you guys are, I think, already exhausted with too much of information. Or should I continue the session? What do you say? But anyway, we just have 3 minutes left, and we'll continue on Tuesday. You are already in the holiday mood. I think everybody is going to leave now. All right. See you on Tuesday. Have a great weekend. All right. All right. Bye bye. Have a good day.